All right, today we are going to start Unit 3. Introduction to Polynomials is where we're at. We're going to look at several things with polynomials. We're going to look at putting them in standard form, how we go about naming them, what degree are there, how many terms do they have, as well as talking kind of at the end about end behavior. So lots of pieces to today, a lot of information going to be shared today. Several notes. I'm going to go through the video really quite quickly. If you have to pause it to write down some more of the notes, I certainly can do that. Otherwise, some of the slides are going to go through pretty quick that just have explanations on them. So again, introductions to polynomials. So the first thing we want to talk about is what is a polynomial. And in order to figure out what a polynomial is, we really need to know what a monomial is. So a monomial is just an expression that's anything that's in the form of a times x to the n, where a is just a real number, or just a number, an integer, whatever, a real number, and x to some power. So all of these are just examples of different types of monomials. 5 is just a monomial, monomial. Something that wouldn't be a monomial, it'd be something like 4 over x squared. We can't write that in the form a times x to the n because we're dividing, so that's not a monomial. But monomials are, and we call each of those individual things terms. When you add or subtract monomials together, so you end up with what's called a polynomial. A polynomial is a monomial or the sum of a bunch of monomials. So each one of the monomials is also considered to be a polynomial. When you add a bunch of monomials together, that's more of what we think of when we're thinking about polynomials. So something like negative 9x squared plus 5 has two terms. Negative 9x squared is one term and 5 is a second term. There's just one term here, 4ab squared. It's got a couple different variables, and that's okay. Still makes it a monomial. It's still in the form x to the n, so a to the n, b to the n. And again, you can subtract them as well. So each of these is an example of a polynomial. There can be tons of terms. The one that I just highlighted, has 4 terms. Just each of these individual pieces is a term. So we say that has 4 terms. The first one we had has 2 terms. And we'll put names to those here in just a little bit. So that's kind of what a monomial is and what a polynomial is going to be. So the next thing we want to be able to do, and one of the most important things that we can do with polynomials, is we want to be able to put them in what's called standard form. Standard form for a polynomial. In standard form, the terms are arranged from the largest exponent to the smallest. So we have to look at the exponents. In the case of the example we have up here, x is our variable. Our exponents, we have to look for the largest one, which in this case would be 4x to the 4th. This is our largest exponent. So that is going to be arranged first. We're going to go from the largest exponent to the smallest exponents. Now, one of the things that I like to do that can kind of help me do these is I kind of look at the exponent. And what I do with that exponent is I underline it according to the number of exponents that I have. So this just there's understood to be a 1 there, so I would put 1 line underneath it. 5 doesn't have an exponent, there's no variable, so I don't put any. I would put 2 lines underneath this one, 3 lines underneath this one, and 4 lines underneath that one. Now, when I put it in standard form, I'm going to go start at the most lines down to the least number of lines, and I'm going to take the symbol with it that goes with it. So this in standard form is going to be 4x to the 4th minus x cubed minus 7x squared minus 2x plus 5. 4 lines, 3 lines, 2 lines, and of course I put a third line, 2 lines, erase 2 lines, and 1 line, and then no line with just our coefficient. And that's considered to be standard form. And remember to bring the sign that's in front of them, bring that sign along. Now, the lines not only talk about the number of exponent it has, but that's also what's called the degree of the monomial. The degree of the monomial is the highest exponent of that polynomial. So our highest exponent, and if we've already put them in standard form, it's easy to do. It's just our largest exponent. So in this case, this polynomial, we're going to say at this point is a 4th degree, because the largest exponent that I have is 4. And again, I put it in standard form. Once I've already done it in standard form, it's going to be that first term is going to be where I determine my degree from for my polynomial. The last thing that's on this slide, I believe, I guess there's 2 more things that are on this slide. The next thing that's on this slide talks about, okay, well, what's the leading coefficient? Well, the leading coefficient, by definition, is the coefficient of the first term in standard form. Well, coefficient is just a mathematical fancy word for number. So it's just the number that's out front of your first term when it's in standard form. So in this case, it's also 4, because 4 is the number of my first term. So that's what we call the leading coefficient. And then I talked about this in the first slide. The number of terms, it's exactly what it is. It's how many terms does it have. If we look at this one, we count the terms, whether it's in standard form or not in standard form, it doesn't really matter. It has 5 terms. Okay. And we're going to put names to this by degree and by number of terms here in just a little bit. But we want to be able to do all of these things with any polynomial that we're given. We want to be able to put it in standard form, name the degree, what's the leading coefficient, and how many terms does it have. So let's look at a couple of examples, and then we'll talk about naming them. Okay, so we got these 2 examples that we're going to talk about. First thing we're going to do is put them in standard form. So I'm going to go ahead and underline them. I've got 3, I've got 1, and I've got none. Well, 3, none, 1, it's already done. Okay, so I already have that in standard form. Perfect. Okay, now if we want to know the degree, so SF, standard form, if I want to know the degree of it is the degree of the largest one, of the first one, if it's in standard form. So we say it's a 3rd degree. For now, we call it a 3rd degree. The next thing we talked about was we wanted to know what's the leading coefficient, the LC. The leading coefficient is the number that's out in front of the first term. And in this case, it's 5. And then the number of terms, we count 1, 2, 3. There are 3 terms in this one. Okay, so we've got it in standard form. It was in standard form for us already. The degree, the leading coefficient, and the number of terms. Okay, so let's look at the second one. It looks like we've got 5, 3, 2, 1, and none. It's already in standard form. We don't care that there's no 4 there. It doesn't matter at all. So it's already in standard form for us. Degree, it's the exponent of our largest term, which in this case is 5. So the degree, for right now, we're going to call that a 5th degree polynomial. The leading coefficient, number that's out front of our first term, that's -3. And the number of terms, in this case, 1, 2, 3, 4, 5, it has 5 terms. Easy enough. They're already in standard form for us in this case, so made it even easier. Now, as we were doing these, you kind of maybe noticed that I said for now, we call it a 3rd degree, a 5th degree. And the number of terms is 3 and 5. Well, we can name these according to the degree and by the number of terms that they have. So I'm going to go over this quick. So if you want to take some notes on this, you might need to pause. And I'm going to go over this really quick. But if you need more time to take some notes, just hit pause and you can come back to it. So if we're talking about a degree, if it's a 0 degree, we call it a constant. If it's linear, it's 1st degree. So 1 degree is called linear. So if you had something like x, okay, that's linear. Quadratic is if it's 2nd degree, so x squared. Cubic is x cubed. Quartic is x to the 4th. And quintic is x to the 5th. Okay, so again, if you need to pause at this point, you can pause at this point to write those down. So if we're naming them by degrees, if we look at the one we did, we said that this first example right here, we said that it was a 3rd degree. So a third degree, this right here, means that we could name this a cubic. Okay? According to its degree, it would be cubic. With the second example, we said it was a fifth degree. So fifth degree is right here. Fifth degree would be quintic. We would say by degree it's quintic. And one of the things you're eventually going to be asked to do is you're going to be asked to name them. And you're going to be asked to name them by their degree and by the number of terms that they have. So that's how we name them, by degree. We're talking about number of terms. If there's only one term, it's considered to be a monomial. We already talked about that one. Two terms, we've done two-term things a lot in here, something like x plus 4. Two terms means binomial. Three terms, x squared plus x minus 14. That's called a trinomial. Anything over 3 terms, we're just going to name it according to the number of terms that it has. So if it has 4 terms, it's a 4th term polynomial. If it has 5 terms, it's a 5th term polynomial. We only really care about monomials, binomials, and trinomials. Anything more than that, we're not going to worry about. So if we look at, again, our first example, it has 3 terms, so we would call this a trinomial. Okay, according to its number of terms. So now if you're asked to name it, we would name this a cubic trinomial. Name it by its degree and by the number of terms. For the second example, we said it was a 5th degree, so that we called that quintic, but it has 5 terms. So we're just going to call this a 5-term polynomial, or I would say with 5 terms. So the way I would name this is I would name this because it has 5 degrees, so it's a 5th degree, so I would call it a quintic polynomial with 5 terms. And that's how I would name this. Name it by its degree first, and then by the number of terms. Okay. And try to get those, I forget, the linear, the quadratic, the cubic, those. Quartic is 4, quartic, I don't know. Quintic, I don't know. I use the quarter one. Quartic sounds like a quarter. There's 4 quarters in $1. I don't know. I don't remember them. Maybe that'll help. Maybe I don't. Whatever works best for you. But get those names down. Okay, so let's look at just some examples of doing this. All right, so we've got several things we're going to do with this one. We're going to write it in standard form. Okay, I'm going to do that first. Oops, sorry about that. So 3 gets no underlines. This gets 2. This gets 1. 2 has to come first along with the symbol. So negative 5x squared. 1 line plus 4x. There's no symbol out in front of the 3, so it's plus 3. So there is in standard form. It's done. 2, 1, none. Identify the leading coefficient. What's the first number? First number is negative 5. Identify the degree. What's the exponent of our leading term, which is squared? So it's a 2nd degree. Okay, we have a name for 2nd degree. Okay, we call it 2nd degree. Flip back to our thing. 2nd degree was quadratic. So we can call it a quadratic 2nd degree, which is quadratic. And the number of terms, count the terms, 1, 2, 3. It has 3 terms. 3 terms, again, if you can't remember it, you got a chart. It's trinomial. So a trinomial. Name the polynomial. We would call it a quadratic trinomial. And you're done with the example. Okay. All right, so now if you want to go ahead and do this one yourselves, you want to press pause for a couple seconds, you can go ahead and press pause. I'm going to just go right into it. If you want to press pause right now, come back and we'll go over it. So 2 lines, no lines, 4 lines. So 4 lines comes first. So 8x to the 4th. 2 lines is next, so plus 3x squared. No lines is next, minus 4. leading coefficient, the number out front, that's 8. Identify the degree, it's a 4th degree. We talked about this a ton, as long as like a quarter, quartic. Identify the number of terms, it has 3, so we call it a trinomial. So we name it, it's a quartic trinomial. If you can read that, you're off better than I am. Sorry. There it is. Hopefully that kind of straightens those up and you're able to do those 5 basic things. So the next thing we're going to talk about is we want to be able to kind of graph these to some extent. We want to be able to graph these. And that's what we're going to be kind of working on towards the end of this chapter, is being able to graph these. So when we're graphing these, we've graphed polynomials before, we've graphed linears, we've graphed quadratics. They have what's called an end behavior. And the end behavior of a function is a description of what happens to the graph if you extend it to the left and to the right. So this end behavior, its end behaviors are in, if you remember the quadrants, okay, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay, that's really well how you do 4 in Roman numerals. This is quadrant 4, IV. This one has its end behaviors in quadrant 1 and quadrant 2. The end behaviors for the second example are here and here. So its end behaviors are in quadrant 2 and quadrant 4. So those are their end behaviors, and there are specific things that happen according to the degree of the polynomial and the leading coefficient that helps us with the end behavior. And we want to be able to tell the end behavior. So there's 4 specific things that can happen. And we're going to deal with what happens with the degree and the leading coefficient. So we've got 4 different graphs that we're going to create. Okay, so I'm going to try to cheat here a little bit, see if it'll let me cheat a little bit. I'm going to copy this. And then I'm just going to paste it, and I'm going to make another one, because there's going to be 4 of these. And another one. And another one. So there's 4 of these that can happen in 4 different situations. So the first degree we could have, when we're talking about degree, remember we're talking about the degree of, when it's in standard form, the exponent, that first exponent. So it can either be 1, 2, 3, 4, 5, 6, blah, 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 blah. Well, the other thing that those have in common is one's even, one's odd. So what happens if it's odd? So what happens if my degree is odd? Say it's 1, 3, 5, dot, 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 dot. And the leading coefficient, the number out front. It can be a whole bunch of numbers, but it can only be one of 2 things. It can be either positive or it can be negative. So let's say the degree is odd and the leading coefficient is positive. Okay, so we've got a positive leading coefficient and it's odd. The end behaviors for that graph, I've kind of run myself out of room. I don't really have enough room here. Let's see if I can move this stuff just a little bit. There we go. So we've got an odd degree and positive. Odd degrees and positives, you think about a line. Lines kind of go this way if it's linear. So if it's odd and positive, it's going to go out a quadrant 1 and quadrant 3. So quadrants 1 and quadrant 3 is where it's always going to start and end. It's where its ending points are. We really don't say start, end. We just say ending points. But for reference, it's going to start, let's say, in the lower left and end in the upper right. That's if it's odd, 1, 3, 5, 7, so on and so forth. And the leading coefficient is positive. Quadrants 1 and quadrant 3. You can do different things. It's not going to be a line. You know, it might be like this. It might be like this. It could be a bunch of different things. But when it's going, it's always going to kind of come out the start in the left-hand corner, lower left, and end in the upper right. If the degree is odd, so the same things, 1, 3, 5, 7, but the leading coefficient is negative. If it's that, then it's going to be in quadrants 2 and 4. So odd and negative are quadrants 2 and quadrant 4. Kind of think about that downward slope of a linear. It goes downhill. So that's downhill. It's going to go start in quadrant 2 and end in quadrant 4. Upper left, lower right is what those are going to look like. So we've got odd and positive. We've got odd and negative. Well, that must mean we also have even. So we're going to have even, and I'm just going to put a plus sign. So even and the leading coefficient is positive. You think about our parabolas. Okay, degree is even. We're talking about x squared, x to the 4th, x to the 6th, so on and so forth. The degree itself is even. Leading coefficient being positive. Think about our parabolas go up. Okay, so if it's positive, it's going to be out in quadrants 1 and quadrant 2. So that's our end behaviors, 1 and 2. If it's even and negative, I'm just going to put a minus sign. If it's even and negative, it's kind of that down where our a value is negative in the quadratics that we've done in the past. Then the end behaviors are going to be here and here. It's going to go down. That a is negative. And it doesn't matter what it is. Again, it can do different things. It can just be a quadratic that looks like that. It could be to the 4th power, a quartic that maybe looks something like that. But its end behaviors are going to be in that 2nd and 4th quadrant if that leading coefficient is negative. So that's the end behavior. So again, if you need to pause it right now and kind of doodle down those things, pause her down and doodle those things. All right, so let's take these and let's talk about the end behaviors of these. So we want to describe the end behaviors of each polynomial. So again, it's kind of important that you have it in standard form already. It's in standard form. The only other things we need once it's in standard form is we need to know the degree if it's odd or even, and we need to know if the leading coefficient is positive or negative. So if I look at this first example, it's already in standard form, so we're good. The degree is 3rd, so this is a 3rd degree. Okay, 3 is odd, so this is odd. Our leading coefficient is 3, and it is positive 3, so that's positive. So this is an odd degree polynomial with a leading coefficient that's positive. So the way we're going to describe the end behaviors is we are just going to draw where those end behaviors would be. So it's odd and positive. Odd and positive is 1 and 3. And you're done. You move on to the next one. Okay. Negative 4x plus 2. It's already in standard form. Degree, there's understood to be a 1 there. So it's a 1st degree, which I think we called linear. So 1 is odd, so it's going to be odd. Our leading coefficient is negative 4, so that's a negative leading coefficient. So we've got odd and negative. Odd and negative is 2 and 4, that downhill line. That's just a line. If we were to graph it, that would go down. The next one, negative 5x to the 12th, and so on and so forth. It's in standard form. We're good there. We look at the degree. It's 12th degree, so it's 12th. 12 is even. Leading coefficient is negative 5, so that's a negative. So even and negative is what we pounce on. Even and negative is 3 and 4. And then the last one, even, 2nd degree, so that's even. Leading coefficient is 3. 3 is positive, so even and positive. Even and positive is here and here. Parabola. And that's what that is. It's a parabola. Remember, we solved that last using the quadratic formula. It was just what our last assessment was on. So those are kind of the things that we want to be able to do today. We're going to do one more example. I'm going to, again, you can pause this one. We're going to have you answer a bunch of questions with this one. Let's go 6x squared plus 2x cubed minus 4x to the 4th plus 3. So the first thing I want you to do with this one is I want you to put it in standard form, SF. After you do that, I want you to tell me what the degree is. Next thing I want you to do is I want you to tell me what's the leading coefficient, the LC. Then I want to know the terms, number of terms, the number of T, number of terms that it has. Name it. What's the name of it? And then the last thing I want you to do is I want you to do the end behavior. And the end behavior we are just going to describe as on our graph. You can pause the video, try this out, and we'll go over it in a second. Okay, so here we go, standard form. I'm just going to go ahead and underline 2, 3, 4, and none. So 4 goes first, so negative 4x to the 4th plus 2x cubed, 3, plus 6x squared plus 3. Degree, I look at my first term. My first term power is 4, so it's 4th degree, which we said was quartic. Leading coefficient is negative 4. Number of terms, 1, 2, 3, 4 terms. So we just say with 4 terms. So if we're going to name this, it's a quartic with 4 terms. The end behavior. The end behavior, we look at the degree. It's a 4th degree, so 4 is even. And then we look at the leading coefficient. The leading coefficient is negative 4, so it's even and negative. Even and negative, our end behaviors are in 3 and 4. So there's just not quick, 28 minutes, lesson on polynomials and being able to name them, put them in standard form, and end up finding end behaviors. Make it a great day, everyone.